Okay, for example, like 2x squared minus 1 to the 5th power. So it's the 5th power, and remember the 14641 that we were at before, right? You don't have to draw the whole triangle. If you remember a row, you can just go from that row down. So the next row down, put a 1 here. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And 1. So that's the row we need. 5th power. So again, the power row is still this one here. We're looking at the 5th power. So, oops, that's impressive. So 2x squared minus 1 to the 5th power. So if I'm constructing Pascal numbers, or Pascal's triangle, the expansion of this, the first number is 1. The first number is always 1. Now, if you take a look at the pieces of this expression, I've got a 2x squared, which I'm going to raise to the 5th power, and I've got a negative 1 that I'm going to raise to the 0 power. Again, so you always start off the first term. The first object in the parentheses goes to the power that you're dealing with. The second term goes to the 0 power, always. All right? And notice I put negative 1 there because it says minus 1. And again, you have to account for negative signs when you do this. The second term is plus 5. Then I'm going to do 2x squared. I'm going to decrease that power by 1. Negative 1, I'm going to increase that by 1. So once you got the first term created, it's just these two guys always end up there. It's just the powers are counting down. 5, 4, and then count out 0, 1. All right? Next term. Let's go with blue. So we get plus 10. I'm going to do 2x squared to the 3rd, and I'm going to take negative 1 to the 2nd. Next term has a 10 again, so plus 10. I'm going to take 2x squared and negative 1 cubed. The next one is 5. So we get plus 5 times 2x squared to the 1st times negative 1 to the 4th. And the final one, I'll do it in orange, plus 1 times 2x squared to the 0 times negative 1 to the 5th. All right. Notice what the negative 1's doing. Even power positive, odd power negative. Even power positive, odd power negative. Even power positive, odd power negative. It's going to be 1 every time, or negative 1, but it's just alternating the signs. So if you just get that in your mind, all you really have to focus on is the first two pieces. Too much. There we go. So we start off with this first term. 2 to the 5th is 32. X to the 10th. When you take a power to a power, you multiply the powers. Negative 1 to the 0 is positive 1, so we just get positive that. Next term. I'm going to get minus because of the negative 1 to the 1st power. 2 to the 4th is 16 times 5 is 80, and then x to the 8th. Next term. Negative 1 squared is positive 1, so we're going to go positive. 2 cubed is 8 times 10 is 80, and 2 times 3 is 6. Next term, negative 1 to the 3rd is going to be negative. 2 squared is 4 times 10 is 40, and x squared is x to the 4th. Next term, negative 1 to the 4th is going to be positive. 2 to the 1st is 2 times 5 is 10. X squared to the 1st is just x squared. And then finally, negative 1 to the 5th is negative. 2x squared to the 0 is 1 times 1 times 1 just makes 1. So that would be my product of those 5 binomials. And just to give you an idea, that one by hand, 2x squared minus 1 squared twice, you get that product, and you still got to multiply that product times 2x minus 1 again. This took the same amount of time. Okay, so as the power gets bigger and bigger and bigger, this takes about the same amount of time. The other one keeps on adding, you know, a bunch more multiplication. So this is the most efficient way as we go forward. Squares are still just do the shortcut. Cubes on up, I would use this technique.